All right, let's look at our next model. This is kind of a home grown version, similar to like a model view controller or maybe a model view presenter, depending on how you look at it. So again, we have our layout here, our XML file, and we have the main activity. We're going to pull the tip calculation logic out into a separate class. And this is what is traditionally done in Android development. And again, like 4 years ago, this is kind of standard practice, is just to pull the logic out and put it into its own class. Now we want to separate these two here, and so we're going to actually add some interfaces in here so that the main activity can get information from the tip calculator, but also the tip calculator can update the main activity here. So again, this is what I kind of classify this as a model view controller more, assuming this is the controller here. The controller or the data model can access the user interface in different ways. And so some people would say that this is the view, this is the controller, and this is the data model. My view is that maybe this is more of the data view, and this is a controller. And we don't really have, and we don't really have a data model here because we don't need a data model for a tip calculator. Basically, this is the view controller model because again, no backend data. All right, let's look at how this is. So we're going to go into our main activity here, and we're going to pull out our tip calculating logic. So in our main activity, we've gone in here, and in the on-click button where we used to do our calculation, we actually created a tip calculator object, and then we're just having it calculate the field. So we're passing it in the bill, the number of parties, and then whether or not it was good service. So we pulled that logic out into a tip calculator class here. And then we mainly have just one method here, calculate. And again, bill Boolean for the good service and the number of people. And we do that calculation here where we check if they're good service, we calculate the bill here. Now, we calculate two things. We calculate the total tip and the tip per person. And we want to get both those things back to the user interface. So we can't just return an integer here because again we have two different things. So we could break this up into two different methods here. We could create an object and pass that object back, but instead what we're going to do is allow this object to update, to send information back to the view here. So inside our main activity, we're creating a method called update view and providing it the total tip and the tip per person. And so we're going to pass that information back, and then this will update the view. Now, you say, why is there any reason why we can't just update this directly? Well, again, it's challenging. We can't update the view directly from another class here, so we have to do it from within this class here. So once we calculate this, we call this update method back into our main view for this. So in order for this tip calculator to be able to access the view correctly, we need to give it a link to it. So the main activity creates the tip calculator and instantiates it. So the main activity can certainly access this tip calculator object. But how does this tip calculator then get back to the main activity? What we do is when we instantiate the tip calculator, we pass the main activity, pass this back to the tip calculator. So when the tip calculator has its constructor, it's given the main view, and it saves that here. So then it can use that variable here to call this method back here, call update view. And this is a common practice where you have one object create another object and pass a copy or a reference to itself so that the other object then can call back here. So these two objects are tied together. So in our layout here, we've got our main activity tip calculator, and the main activity can call calculate here, and the tip calculator can call update the interface here for this. Now we want to add some separation and maybe be able to swap things out. So maybe we have some complicated logic here, and we want to, here we have Android interface. Maybe we want to plug in later on an iOS interface or a web interface here. And so we're going to put some interfaces in here for this. And again, we have these two different calls, so we're going to put in two different interfaces. here. So again, we just defined two different interface, an iCalculate interface. I mean, what does the main activity need to do to the calculator? It just calls one method a calculate method. So we'll just build an interface with that one method in it. And then what does the tip calculator need to do back? How does it need what does it need to access back in the main activity? And it just needs to do this update view. Call this one method here to update the view. So we have another an update view interface with just that. So these are just interfaces here, really simple interfaces that do one thing. But again, the idea is that this follows some of our software design stuff where now our object here are classed in multiple things. Besides organizing the interface, it also calculated the tip and did that logic. And so here we're going to break that up so that the tip calculation stuff is in a separate object, and this main activity only focuses on coordinating and interfacing with this layout thing. And then we also added these simple interfaces so we can plug in different maybe front ends into this back end stuff. So that's a good basic layout, but it has one of the problems in that it doesn't follow this. Well, it doesn't. It's not. This is not really part of the Android ecosystem, and let's show you one of the problems with that. So one of the strange things about Android is how it handles rotations. And when you rotate the screen, it actually quits your activity, destroys your activity, and recreates it in a different layout for this. And on create, and the whole activity is destroyed and recreated. And you'll see that now. Let's say we're doing this, we do some calculation here. So we have our values here. But now if we were to rotate our screen to, let's say, show it to someone or something like that, okay, I just realized that the emulator I was running doesn't actually simulate the screen. It doesn't actually do a rotate on the screen. So I'll explain it. So when you rotate your screen, these amounts, the tip calculation amounts that you calculated, are erased because again, it restarts the whole activity. And so one of the problems is that we lose a lot of information. And this ties back to kind of the way this is set up. Let's go back up here to this example talking about view models and how this works. So when we recreate an activity, okay, so when we create an activity or run an app, it calls this on create. It also calls a start and resume, and the activity is running. But when we rotate the screen or something like that, our process is restarted and we'll recreate the activity. So the process is killed and the activity is killed and we restart the activity. So in our architecture, this in activity main is actually the on create is not just called at the beginning, but it's called every time we rotate our screen and set up. So we're going to switch to a different architecture here, the view model architecture, and that'll be our next video.